Hello students, how are you all? Today I've made another video for you which involves the solution to Countdown second edition. You can see the front page of this book on the screen. This book is of second edition and it is mostly used in class 7. I have created the video on the solutions of chapter 4 which is all about square and square roots. Before starting off with the solutions to exercise, I would like to discuss some of the important definitions that you must know before starting this chapter. The first definition that you must know is what is a square. When a number is multiplied by itself, the product is known as the square of that number. You can see the examples given on the right hand side of this page. Whenever I multiply the same number twice, it gives me the square of that number. For example, 1 into 1 is 1, 2 into 2 is 4, 3 into 3 is 9. It goes on and goes on according to the counting. So a number is when multiplied by itself gives me a square number. Now we will learn what are perfect squares. A perfect square can be expressed as a product of two integers of equal value. For a number to be a perfect square, the two integers which are multiplied should be of equal value, means that they should be same. I've given some of the perfect squares to you on the screen on the left hand side. You can see that the square of 2 is 4, the square of 3 is 9, the square of 4 is 16. So this goes on as the counting goes on forward. But for it to be a perfect square, the two numbers have to be same. Now on the right hand side of this screen, you can see an activity in which you have to identify which of them are perfect squares and which of them are not. If you see part number 1, 16. 16 is said to be a perfect square because I'll multiply 4 two times, which is of equal value, and it will give me 16. But if you move on to the number 15, 15 is not a perfect square because there is no such number which can be multiplied twice and you get 15 and which is of equal value. You can get 3 multiplied by 5, 15, but 3 and 5 are not of equal value. So 15 is not a perfect square. This is how you can further identify the perfect squares or the numbers which are not the perfect squares. Now finding the positive square roots of any number, the method which you are going to use is the method of prime factorization. It is a very simple method which kids of class 4 and 5 and 6 have already studied. Prime factorization is when a number is expressed as a product of prime factors. Now you remember that prime factors are those numbers which only come in their own table, like 3, like 5, like 7. They only come in their own table. They do not come in any other times table. So you have to make prime factors. The numbers should be prime of any number for which you have to take out the square root. In this example, you can see that I'm going to do the prime factorization of 40. And I'm going to start by 2 because 2 is a prime factor. So 2 20s are 40. Then again 2 10s are 20. Then again 2 5s are 10. And then 5 1s are 5. All of the factors are prime. And then I can multiply all of the factors with each other to give me the final answer of this question. So 2 raised to power 3 multiplied by 5 will give me 40. So this is how you are going to make the prime factors of every number for which you have to take out the square root. This is the chapter that we are going to discuss today. It's chapter number 4. It starts from page number 47 of your countdown books, edition 2 for class 7. Let's move on to the solution to question number 1, part 1, exercise 4a. I'm going to discuss part number 1, 2 and 3 of question number 1, exercise 4a. You can see the little picture of the book which has been taken from the book, so you can find the relevant question you want. Question number 1 says find by factors the positive square root of 529. So this is the prime factorization method that I'm going to do. 529 will be written here and 23 on the other side. And this one is very simple because there's only one prime number in which table 529 comes, and that is 23. So when you multiply 23 with 23, you get 529. I'm going to write it the way that is shown on the left hand side. 23 multiplied by 23 is 529. So 23 raised to power 2 is equals to 529. If we take under root, the raised to power 2 will be cut by the under root and your answer will be 23. Part 2 is a little lengthy because the number which we have to take out the perfect square of is a big one. The number is 1024 and you have to take its perfect square by doing the prime factorization. So we will start by dividing it from 2. Now I have done some rough work on the right hand side of this screen so that you can do the long division method to find out that in how many times in 2 times table does 1024 come. So if you divide 1024 by 2, it will give you 2 5s are 10. 10 minus 10 is 0. 2 will be carried down. 2 1s are 2. Then you 2 and 2 will be subtracted. You get 0. And then 4 comes down and 2 2s are 4. So 4 minus 4 is 0. And your final answer the is 512. And when 2 is multiplied by 512, you get 1024. This is how you can follow all the rough work and divide each and every number by 2 to get the prime factors. I am using 2 because it is a prime number. You cannot start this question by using 4 or 6 or any other number if the number is composite, because we have to stick to the method of prime factorization. So after your prime factorization is done, you are going to write all the factors as shown below. Then you are going to write them with raised to power 2 because we are finding the square root and we are going to make the pairs of two 2's each time. Then the raised to power 2 will be cut by the under root and your final answer will be 32 because we get 2 5 times and 2 if multiplied 5 times you get 32. Now we are going to find the square root of 1225. 1225, and as you can see it doesn't come in 2 times table or 3 times table. So the next prime number that we are going to use to divide this is going to be 5. I've done a little rough work as well. 5 2's are 10, 12 minus 10 is 2, and then 5 4's are 20. When you minus 22 and 20 you get 2. 5 carried down makes 25, so 5 5's are 25. So when you multiply 5 by 245 you get 125. The next step will be same, done in the same way using the long division. You are going to divide 245 by 5 and the answer you get is 49. Now 49 is the square of 7. So 7 is the prime number which we are going to use and divide 49 with. So 7 7s are 49 and 7 1s are 7. You get 4 factors which are 5 into 5 into 7 into 7. Then you take common from each pair. Take 5 one times, take 7 one times, and when you multiply them, the answer is 35. So 35 is the perfect square of 1225. Our exercise 4A, question number 1, part 1, 2, 3 are completed now. I hope you understood them very well. I want all of you to try the exercise and let me know if you can solve it yourself or not. All math lovers, please subscribe, like, share and comment on my channel for more math conceptual videos. Thank you.